Anyway, here's number one from the first study guide. So 9th and 10th grade students were surveyed about a new song. They could rate the song from 1 to 10, with 10 being the best. Here are their ratings. And the students' ratings are placed into two categories: worth listening to for ratings 6 through 10, and not worth listening to for ratings of 1 through 5, and you're filling in the table based on that. So let me kind of copy it so that way I don't have to keep scrolling. But sometimes to try to trick you, they'll not put the total row or total column. So if that is not there, consider adding it like on your scratch paper. And then also know that they're putting worth it as 6 through 10, so a score of 6 through 10, and not worth it for a score of 1 through 5. So then looking at our data, so here's like the 9th grade column. I'm just going to count all of them that are 6 through 10. Okay, so I counted 4. If you get a number other than 4, tell me. But I went through that column for 9th grade and counted all the 6 through 10 scores. So then I now count my 1 through 5 score. And I counted 10. Again, correct me if I'm wrong, but that's what you're again. Now for 10th grade, the worth it, 6 through 10, I'm gonna count all those. Counted 5. And then for not worth it, 1 through 5, it's 5 also. So then for your total rows and total columns, like for my columns, it would be 4 plus 10 is 14 total 9th graders were surveyed. 5 plus 5 would be 10 total 10th graders were surveyed. And then for the rows, I would add the rows for those totals. So like 4 plus 5 would be 9 total said that it was worth it. 10 plus 5, 15, not worth it. And then the total that goes here should be equal to the amount of people surveyed. And you can do it from your row total or your column total, but it should be the same number. If it's not, then you must have added something wrong at some point. But like 14 plus 10 is 24. 9 plus 15 is also 24. So it looks like it all checks out. The rows should add to the row total, the column should add to the column total. And then you're just filling it in here. So questions on that one? So you have to be able to do it from like a little paragraph of information. I think this one was pretty easy on the study guide, but I know like a lot of them that you'll see, they'll give you maybe total 9th graders, maybe they'll give you the total that said not worth it, and they'll make you fill in those gaps. So just make sure like no matter what they give you, start with that and then fill in those gaps, knowing that they have to add up to the rows and columns. So questions on that one? Okay, questions on others from any of the study guides? Jaden? All right. Okay, so students were asked about what their favorite sport was at different ages, the relative frequency table, and know that relative frequency just means that it's going to be displayed like as a decibel or percent. But it shows the results. So don't get confused by that. Like it's not telling us how many were surveyed, but just know like the math is still going to be the same. Okay, so when it says which of the following statements are true based on this information, well, you just have to read each of these carefully. Like I could throw a lot of vocab at you, but like at the end of the day, you just have to read it carefully. So like, and it's probably shuffled on yours, so make sure like you pay close attention. On my screen, A says the probability that a student likes baseball, given that the student is between 11 to 13 years of age, is this value. So anytime it says things like given that, or among those, or out of, whatever follows that is gonna be your denominator. So we're saying basically out of the students that are between 11 to 13 years old. Let me go back to the table. How many, and I know we don't know exactly how many, but we know the decimal. What's the total for students 11 to 13 years of age? What box in this would be my total 11 to 13-year-olds? So the question is, what's my total 11 to 13-year-olds? What decimal does it say for my total 11 to 13? 0.35. So anything that follows given that is going to be your denominator. So students between 11 to 13 years of age, this is my denominator. And we want to know out of these kids, turn out the box. Out of these kids, how many like baseball? So what would I put? So baseball kids. So I need to divide that out, and if it equals 0.34, then that would be true. So let me see. 0.12 divided by 0.35 is 0.34. Did I already find my answer? Let's see. I feel like it wasn't that earlier unless they reshuffled it. So out of the kids that are 11 to 13, 0.12 like baseball. Yeah, 0.34. So it looks like I already found my answer, but let's just make sure. So like in B, for example, that one says the probability that a student is between 11 to 13 years old, given that the student likes baseball. So these sound really similar, but the division is going to be different. So anything that follows given that, or among those, or out of, is going to be your denominator. So how many total students like baseball? According to the table. 0.25. So right here, this would be my total students that like baseball. I know 0.25 isn't like a fraction of a person, but they gave us a relative frequency, so we have to go based off of it. So then out of these kids, what's the value for 11 to 13-year-olds? David? Out of those kids, what's the value for 11 to 13-year-olds? No. So we want to know basically, given that a student likes baseball, how many of them are 11 to 13? No, this is my total that like baseball. Here's where it breaks down their ages. How many of them are 11 to 13? Good, so 0.12. And then you divide those. And that does not equal 0.34, it equals 0.5. So that's why B is not the answer. It's different because which we following is true. Make sense? Okay. Let me see what it says up here. So yeah, it must have shuffled each time I viewed it. But so on my screen it's A, but like see the difference. in what we're even looking at the different parts of the table. Let's do one more, let's do C. So C says the probability that a student is 14 to 16 years old, given that the student likes basketball. So again, what follows things like given that, among those, out of, that is your denominator. So how many total students like basketball up here? Let's see. Ryan, what's my total for students liking basketball? Okay, good. So when it says, given that they like basketball, that needs to be my denominator. So then out of these kids that like basketball, the question was the probability that they are also 14 to 16 years old. So what number would be for the 14 to 16-year-olds? 0.08. And then when you do that math, 0.08 divided by 0.35, that's 0.23. And that is not what C said. C said it would be 0.08, but it's not 0.23. So questions on how to do that. All right, so for more understanding, know that like relative frequency tables are based off of like the grand total. But these questions are not based off of all the people that were surveyed. They're based off of like certain people, like kids 11 to 13 years old, or kids that like baseball. So when it's not based on the grand total, I can't divide by the grand total. I have to divide by whatever like subsection of people we're talking about. So questions on this one? All right, questions on others? Really? Is that a hand up or? Okay, questions on any other part of the same thing? Okay, well then you let me know. We still got 15 minutes left and take the real thing tomorrow. So regardless of whether you've been here or not, or whatever reason, whatever good reason you have. So expect high scores from these videos, so that's practically showing you the test and not the help today. But yeah, let me know when and if you have more questions.